Chapter 7 Special Functions. B. Energy efficient lighting through presence triggered light control. 1. Targets and requirements. Today, building standards and national as well as international energy saving laws together make it necessary to design energy efficient lighting systems in order to receive the demanded energy efficiency label A for the building. The targets are reducing the amount of energy per square meter and year below the limits ruled by law and standards and still achieve comfortable working and living conditions. The first step to reach this goal is using energy efficient lamps, which seems to be solved today because no incandescent or halogen lamps need to be used anymore, but fluorescent tubes and LEDs are available for all kinds of luminaires. The second step is to establish automatic control functions that operate the lighting system only if required. These are the controls the KNX-DALI system can provide. A. Operate the lights only when presence is true. This requires presence detectors. B. Dim the lights always to the minimum level necessary for the users of a room to perform their job undisturbed. This requires a closed-loop light level control. C. Lock the comfort operation during times of absence to the after-hours mode. This is done by a scheduler. After hours, also called night mode, means time and level controlled manual switching. 2. Parameters for presence detection and light control. There are various influencing factors to be heeded. For all of them, certain parameters have to be set. Please note also that at first the different function blocks are designed separately and then linked to each other via their KNX communication objects. So it is always possible to combine KNX and DALI functions wherever it makes sense. A. Presence operation and timer settings. First of all, you see that there are two channels called presence and HVAC. However, you have only one sensor. Basically, they are identical. So actually, you can derive two different reactions to this sensor which operate two different functions. For example, a brightness-dependent operation makes sense for lighting control, but not for HVAC. To count the number of presence triggers within a certain period of time makes sense for HVAC, but not for lighting. If the room consists of more than one group of luminaires, the decision has to be made if all of them shall be controlled by one controller, then in the mode main control plus extension sensors, or individually. That means each presence sensor controls only one group. The parameter is device mode, single or main device or subgroup. Then the operation mode itself has to be determined. There are three main options referring to the parameters begin and end of detection. Fully automatic. The lights turn on when presence or motion is detected. The constant light level controller is also turned on. When the presence condition is not true anymore, after an overshoot time, the lights will turn off. Semi-automatic off. Same as above, but the control must be turned on manually. The begin option is send no telegram. Semi-automatic on. Same as full automatic, but the control must be turned off manually. The end option is send no telegram. Further settings for the present sensor. You can lock its function by a 1-bit object. This is required if you want to change between day and night operation mode. Then, if the sensor only shall be used for simple on-off control, the detection brightness threshold needs to be defined. In case another light control is to be triggered, make sure that this factor is set to 0. The parameters interval for presence detection and amount of minimum detections during interval time belong to one another. If the interval for presence detection is not disabled, 0, then presence will only be true if the parameterized minimum amount of motion triggers is counted within this interval. Downtime after end of detection. It is also called dead time and means that the on telegram A will be suppressed within this period. This timer is required to avoid self-triggering of hot lamps which are in the detection range of the sensor when they are turned off by their own temperature change. Delay timers. The time delay after end of motion detection to send telegrams C and D. Brightness measurement. The dual sensor measures the brightness level at its place. This is normally the ceiling, but you want to control the brightness on the desk area below. The sensor can only measure the reflected light level from the desk, so there is a certain attenuation which needs to be retrieved and entered as adjustment factor. How you can find a good approximation of this value is described later under calibration. Sending brightness values. The following parameters are mostly self-explanatory. If you want to see the measured brightness, for example on a display, you must set up the way how the values are sent to the KNX. Don't choose cyclic repetitions too frequently, as well as the relative difference not should be set to a value below 5%. The absolute difference sets a further limitation to excessive numbers of bus telegrams. B. Light control. Here at first we have to decide if a simple 2-point light control is sufficient or nothing else possible, for example if there are no dimmable ECGs, or if the more enhanced and energy efficient constant light control should be used. As you can see, the amount of parameters for the 2-point control isn't big. Actually, the two switching thresholds for on and off have to be set, and if they are fixed parameters or flexible via object. Further on, the on-off delay timing and the scenes that turn off an active 2-point regulation. For the constant light control, we have to make quite a bit more adjustments. They are grouped in 5 topics: set point, regulation, controller output main group, subgroups, and calibration. Set point can be a fixed parameter or flexible via object. Then a range must be entered as well. The set point can also be changed and stored via 4-bit dimming function. Finally, it is possible to start and stop the regulation also via the 8-bit setpoint object. 0 turns off, a valid value between the thresholds turns it on. Regulation. The hysteresis determines how precise the setpoint is maintained. It must be aligned with the controller output step width. The control speed can be set between 3 and 30 telegrams per minute. Together with the maximum increment when dimming, which can be 3.9%, the full range of 100%, can be dimmed in 52 seconds. Then we have two parameters for the de- and reactivation of the controller in case the natural brightness is high enough. Begin and end refers to how the regulation starts and stops. Sometimes an additional switching telegram is required. At last, again, the scenes which stop the regulation must be defined. Controller output main group. As mentioned before, the step width or increment for dimming must be set. Don't set it too large, especially when the luminaires are very bright, but the control set point is rather low, because this can cause pulsing of the light. For starting the regulation, we have three options. Adopt from parameter. This refers to a fixed dimming value. Calculate start value uses the characteristic dimming curve of the luminaires and the assumption that it is dark outside. Request from status means that the light controller can precisely calculate all dimming values already from the start, because this time also the natural light level can be calculated. The last two parameters, maximum and minimum dimming value, are self-explanatory. Subgroups. This light controller can operate up to 4 additional extension groups. Their dimming behavior is derived from the main regulation, either using the characteristic dimming curve, this is called dynamic control, or using a static offset. Static offsets are always constant and so have the disadvantage that it isn't possible to have all lights dimmed to the same level at full outside darkness. The maximum and minimum dimming values apply here as well. Calibration. Here the position of the light sensor has to be set. That means which of the luminaires from A to E it is assigned to. The up to 5 entries for measured brightness represent the attenuation curve of the natural light in the room. It must be measured with a calibrated lux meter in the room under each row of luminaires when the lights are turned off. The parameter time until next value defines the delay between the automatic measures for the light characteristic. It is necessary because lights will warm up and so change their light output gradually. 3. Communication objects. A. Basic configuration. For operating a single-channel constant light control, only two objects are required: control on-off and main dim value. B. Enhanced configuration. Normally, you wouldn't stop at the basic level, because for a comfortable solution, it is always required to change the set point at runtime, to see the current brightness level, to distinguish between manual and automatic operation, to start with the current main dimming status, and to operate also subgroups. In this case, between 11 and 16 further objects have to be added. Main dimmer status value, set point, 4 times subgroup control value, 4 stop objects, 1-bit, 4-bit, 8-bit and scene control, room actual brightness, and 5 times switching for each lighting group. C. Calibration. See also next part. There are 2 calibration steps which have to be performed in the commissioning phase. One is the characteristic curve recording, which has an object to trigger it. The sensor calibration, however, does not use an object, but must be done in the sensor parameter dialog. 4. Calibration requirements. A. Light sensor. As mentioned above, the light sensor usually measures indirectly, so you must figure out the ratio between the sensor measurement and the true light level on the desk surface. The procedure for it is as follows. It is an empirical fact that you must do it in the situation of 50% natural light and 50% artificial light at the required set point. This is the worst case point, strongest influence of side effects by stray light. Example: your set point is 500 lux. For the calibration, the natural and the artificial light level must be 250 lux each. Take a lux meter, put it on the desk below the master sensor, and operate the blinds until you measure approximately 250 lux. Lights are still off. Further, you dim the lights up in order to achieve the 500 lux set point. Always make sure your natural light level stays constant. In the live commissioning dialog for the sensor, you will see the ratio between measured and true value immediately. B. Lamp's characteristic. The dynamic light control requires the knowledge of the lamp's dimming characteristic. That means the curve of light level over the dimming values must be retrieved. This curve will be recorded automatically by the DALI controller when the calibrate object is triggered. You only have to make sure that the environment of the luminaires is absolutely dark. External light will deteriorate the measured curve or even completely spoil it. What does this calibration step do? The controller sends 15 dimming values in ascending equidistant order to the luminaires. Then, after a certain delay, it measures the light level of the sensor and stores it together with the dimming value in a reference table. If you want to see and save the value pairs of this table, make sure you have the object diagnostic lux value linked with a group address and the group monitor running. After a successful recording of this characteristic curve, the DALI gateway will send all measured lux values in ascending order via this object. This table is always required with extension groups and also is unneglectable if you want to start the light control with a calculated value. This is the parameter first dimming value if regulation begins in the constant light control page. 5. Practical demonstration. To give you an impression how a dynamic constant light control with 5 groups works, I have prepared the following configuration. Here you see a DALI lightbox, which is used for training and demonstration purpose. It consists of 2 parallel RGB color light strips controlled by a 3-channel DALI ECG. An Osram LSPT dual sensor is placed between the light strips. The red and blue LEDs make up the main lighting group. The green LEDs are used as daylight simulation. The additional lighting groups as extension are only virtual. The first step is the sensor calibration. Default gain is 1.0. The measured value, in this case, the so-called raw value. For the test box, I make the assumption that 50% of daylight, the green LEDs, plus 50% of red, blue or magenta light makes 600 lux. I change to the sensor commissioning dialog. The right column shows the button Calibrate. When you open it, you can see the current measure of the sensor and the gain. I simply enter 600 lux here, which returns a gain of 3.9. This value is synchronized with the corresponding parameter of the sensor, but still must be downloaded. I close the parameters and run a partial download. After the download, the feedback of the brightness sensor changes to 609 lux. After this calibration, the second step is to record the dimming characteristic of the main lighting group. As the DALI light controller sends all telegrams, including the present brightness value, I open a group monitor and filter for all telegrams with the source of my DALI gateway 1.1.2. I start the calibration now. You can see that it starts with switching on telegrams to all lighting groups. Only then it can send the 16 dimming values in ascending order. The values are easy in hex reading, starting with 10, always counting up by further 10 hex until reaching FF. Since the current values for the group addresses are also sent, I show them in the column Last Value of the group window. Finally, all values will be sent out one by one through the object diagnostic value. From now on, the light control works, and you can start it either by sending an on telegram on group light control on-off or a valid set point value. With an off on group light control on-off or a set point of 0 lux, the control stops. I start now with set point 500 lux. As you can see, it is achieved by a dimmer control value of 68% of all groups at no daylight. I add some daylight now, 25%. The control values now start to differ from each other as expected. When I apply 100% daylight, the main group drops down to 1%, while extension group 4 still remains at 59%. Thank you. You have reached the end of Chapter 7b, Constant Light Control.